So 13.7 talks about division of polynomials. Now, remember that I said a rational expression was polynomial divided by polynomial. And we spent a lot of time putting polynomials together, right? Adding and subtracting, putting them over a common denominator, all that good stuff. So it should come as no surprise that we can reverse that process. Right? Everything in math is a two-way street. So I'll start with something relatively easy. How could I handle a plus b divided by c? How could I do that division? Well, it's a common denominator, right? So you have a over c plus b over c, reduce if possible. And that's it. That's not too bad, right? I mean, it is where we're starting. Same thing if you have a minus b over c. As long as you have everything over a common denominator, you can split it apart, a over c minus b over c. The unfortunate thing is this only works if c is a monomial. What is a monomial? One term. A monomial is one term. No plus or minus in the denominator. That would mess you up, right? Unless it's a negative sign and not a minus. That's different. So, if we are asked divide 16y cubed minus 8y squared plus 6y by 2y. They're asking us to take one polynomial divided by another. But that second one is a monomial, right? 2y is just one term. It's a monomial. So this means, this is the question, we would set it up 16y cubed minus 8y squared plus 6y all divided by 2y. Right? That's what division is, right? And since we're dividing by a monomial, how do we handle this? Break up the common denominator. 16y cubed over 2y minus 8y squared over 2y plus 6y over 2y. Isn't that what that said we could do? Mm-hmm. With a monomial, we can break it up. Does this reduce? We get 8y squared. We get minus 4y, and we get plus 3. Is that okay? So when we divide 16y cubed minus 8y squared plus 6y by 2y, we get 8y squared minus 4y plus 3. Did that divide cleanly? Yes, it divided cleanly. Is that okay? Not so bad. Not so bad as a start. What if we are given 9a cubed b cubed minus 6a squared b squared plus a squared b minus 4a, and then we're given old school division sign. Negative a squared b. So polynomial divided by polynomial, right? Is what we're dividing by a monomial? Just one term? Yeah. Right? I mean, so far that's the only case we've discussed. So hint, that's what it is. So you guys, how should I write this? Write it with the common denominator, right? Yep, for posterity's sake, I'll write the step right before that, but if you're okay jumping straight to the next step, I'm okay with that. So we're going to take 9a cubed b cubed minus 6a squared b squared plus a squared b minus 4a and put it all over negative a squared b. And since we're dividing by a monomial, how that works is to break that common denominator up to each of the terms. So I have 9a cubed b cubed divided by negative a squared b minus 6a squared b squared divided by negative a squared b plus a squared b divided by negative a squared b minus 4a divided by negative a squared b. Do you guys see how I broke that up? Is that okay? Right? It's what a common denominator means. I can either break it apart to each of the denominators, or I can write it all together over one denominator, depending on the direction I'm going, right? Now, we say common denominators, so we can do this with denominators. Have I ever said something about a common numerator?
No.
There's no such thing. So you can never break up a numerator like that. Right? There's no common numerator, no such thing. Right? So let's see if this reduces. So what do we get for that first term? What do we get for this first term here?
-9ab squared.
Very good. Negative 9ab squared. Is everybody on board with that? What do we get for the second term? What's the sign, though? You skipped over an important part. Yeah, it's going to be plus 6b. Negative over negative makes positive. You guys agree? All right, next up. Yeah, it does cancel, but when it cancels, it still leaves 1. How many times will something go into itself? 1 time. All right. Does that make sense? That's a so easy it's hard moment. And what about the last one?
Plus 4ab. Or plus 4 over ab.
Ah, but there's a distinction there. All right, it is plus 4 over ab because we only had 1a up top, so it didn't cancel out the denominator. Do you guys agree? Mm-hmm. So did this divide cleanly? Almost, right? That works if you're playing horseshoes or throwing grenades, but it doesn't work in math. Right? Close is not good enough. So in this case, we might say that we had a remainder. Uh-oh.
Oh, no.
You've heard this word before. All right, because now we're going to level up. So before we actually go into an example in this section, let's go back to elementary school. All right. What if I did 7 divided into 296? Old school. How did that work? Yeah, you don't look at 296, right? Instead, you look at, does 7 go into 2? No. Does 7 go into 29? Ah, how many times does 7 go into 29? And then what do? You multiply that 4 times the 7, right? And that gives you 28. And then what do?
Well, when you subtract those two.
You're going to subtract, so you put a minus sign up there. 28 flips to negative 28, and you're left with 1.
Bring down 6.
Carry down the remaining place values, 6. And what do we do now? Lather, rinse, repeat. Right? 7 will go into 16 twice. And then what do we do with that 2? Multiply the 2 by the 7, which gives me 14. And then we flip 14 to a negative 14, because we're subtracting. And that leaves me with 2. Now, long division is one of those areas in math where neatness matters. Right? If you're one of those people that starts scrawling up the margins of your paper, this is going to be rough on you. Right? Keep your columns as aligned as possible. Now, ain't nothing straight up here, but I can still keep my columns lined up. All right? How do I know that I'm done? I ran out of columns, right? That's one giant red flag waving in your face. Right? What's another red flag that lets you know you're done? Yeah, 7 doesn't go into 2, right? Anybody shocked? 7 is bigger. If you have 7 sheep, you have more than if you have 2 sheep. Right? So what do we say? We say 296 divided by 7 equals 2 with a remainder. What is our remainder? Sorry, 42. Yeah.
42 with the remainder.
Yeah, the remainder, which is already what I was thinking of,
I was going to say, what?
with a remainder of 2. And we can write this in a particular way. Take the remainder and put it over the original divisor. You guys recall this process? Deep, deep, deep in the brainstem. Like, we're talking somewhere on your spine at this point. 296 divided by 7 is 42 and 2/7. All right? Implied here, it's 42 as a whole number plus 2/7 as part of the next number. You guys agree?
Yes.
You really, truly escape nothing in math. Nothing. All right. So long division of polynomials. The good news is it's going to work exactly the same way, right? It's going to look different, but mathematically it works exactly the same way. A couple of key things, though, that we have to keep in mind. Write everything in descending order. All right, that's going to be very important with polynomials. We all remember descending order, right? The second thing is fill in missing places with zeros. So if I don't have a square term, I'm not just going to ignore that squares exist. What should I put in?
0.
I'll put in a 0 for the x squared. All right. So let's say I ask you to divide 10x squared minus 17x plus 5 by 5x minus 1. All right, first, is everything in descending order? All right, good. Am I missing any terms?
X squared.
Yeah, but that's at the beginning, so that's okay. All right, we're talking about more in the middle. So, how do I set up my long division? Well, which is the divisor? Yeah, 5x minus 1, that's your divisor. That's what goes outside. And which one is your dividend? I mean, by process of elimination, it's the other polynomial, right? But it's a word you probably haven't heard of in a while. 10x squared minus 17x plus 5. So we've got our divisor. And our dividend. The answer is called a quotient. So we all good with the setup? Descending order, no missing terms that I had to fill in for. So how did long division work? Did we consider everything over here at once? No, what did we do? We just considered the first part, right? That's all we did. We're going to do the same thing here. All right? Let's just consider the first part. How many times would 5x go into 10x squared? All right. So on the side, I'm taking 10x squared divided by 5x. Right? Some of you guys may get comfortable enough that you can do this part in your head. Wonderful. If you don't, do it on the side. No shame. Right? A right answer is a right answer is a right answer. What is 10x squared divided by 5x? So, how many times does 5x go into 10x squared? The answer is 2x. And where should I put that? On the x column. All right, I have a square column, I have the 1 column, and then I have the constant column. All right, neatness matters. And then what do? Right? We multiplied the 4 times the 7, right? So now I'm going to multiply the 2x times the 5x minus 1, which gives me 10x squared minus 2x. Put the x squared in the x squared column, put the x in the x column. All right, so this is playing the role of that 28. What did we do with that? We were subtracting. So we're going to do the same thing here, and that meant flipping the signs. Right? If you're subtracting, it's going to flip your signs. So what happens? 10x squared minus 10x squared? 0. Gone, right? Negative 17x plus 2x is negative 15x. Right, then what did we do? Carry down the remaining digits, so in this case, terms, plus 5. That's one round of long division. Do you guys see how that worked and how it worked the same way it did for numbers? Because what we're going to do now is lather, rinse, repeat. Again, don't look at the whole thing, just look at the first part. How many times will 5x go into negative 15x? So if I take negative 15x divided by 5x, the answer is negative 3. Do you guys see? All right, again, if you have to show the work on the side, no problems, as long as we get there. So how many times does 5x go into negative 15x? Yeah, since I wrote the answer down, I was hoping more than one person would say it. I have my doubts about you. So that's a constant, goes in the constant column. What do we do with that negative 3? Multiply it by who's playing the role of 7 here, that 5x minus 1. And that's going to give me negative 15x and a positive 3. You guys agree? Right. Negative 3 times 5x is negative 15x. Negative 3 times negative 1 is a positive 3. You guys agree? But then what do? We're subtracting, so flip the signs. All right, you're subtracting, so flip the signs. And what happens?
2. Oh, you left for 2.
Yep, negative 15x and positive 15x cancel to 0, and 5 minus 3 is 2. All right. Okay, how do we know we're done? We ran out of columns. That's one way of knowing, right? Out of columns, right? The next, how many times does 5x go into 2? It doesn't. There's no x there, right? So it's not going to divide any further. And let me see some neck action out of you guys. You guys see how this is an analogous process. Right? Not that I'm just going to cut you loose right now and have you go do long division. we got to do a little more work. Right? But you guys see how this process is really the same. So, (10x squared minus 17x plus 5 divided by 5x minus 1 is equal to 2x minus 3 plus, what's my remainder? 2 what's? Very good. 5x minus 1 is playing the role of 7. So your remainder is 2 over the 5x minus 1. Right. Did this divide cleanly? No, you had a remainder, right? So there's still a fraction there. Same as it was with numbers. Right? Did 7 divide, whatever the number was, 296 cleanly? No. There was still a fractional part, but it's the same process. All right. So what if I ask you negative 9 plus 7x minus 4x squared plus 4x cubed, old school division sign, 2x minus 1.
It's not in descending order.
All right, it's not in descending order. So when I set this up, what's my divisor? 2x minus 1. That's the divisor, right? Then how should I write my dividend? 4x cubed minus 4x squared plus 7x minus 9. Is everybody okay with that? All right, do you see how we rewrote our divisor to be in descending order? All right, so once the setup is good, and we know we're not missing any terms right now. I've got an x cubed, an x squared, an x, and then a constant, so nothing missing yet. How do we do it? Yep, we start at the start. That's a good place to start. How many times will 2x go into 4x cubed? Yeah, some of you guys are pretty good at this. So if you have to see the work on the side, that's totally fine. 4x cubed divided by 2x is equal to 2x squared. So where do I put that? Yeah, in the square column. So I got 2x, that's a little suspicious, 2x squared. And then what do I do? Multiply the 2x squared by the divisor, 2x minus 1, right? What's that going to give me? 4x cubed minus 2x squared. You guys agree? Notice I put them in the right columns, right? Now what? You're subtracting, and that means flip your signs. You guys agree? What's going to happen now?
That cancels out.
Yeah, 4x cubed minus 4x cubed cancels out. And then you get
Negative 2. Well, minus 2.
negative 2x squared. And that's round 1, right? So we finish up by carrying down the remaining terms. So plus 7x minus 9. Lather, rinse, repeat. How many times will 2x go into negative 2x squared? So we have negative 2x squared divided by 2x, which is negative 1x. Is that okay? Are you guys with me on this? Again, if you can't do it in your head just yet, that's fine. Right? Life goals. So I'll put minus x over the x column. And then what do I do with that minus x? Multiply it by the divisor. 2x minus 1. So that gives me negative 2x squared and then plus x, right? And then we're subtracting, so flip your signs, right? And what happens? So have you started to notice when we're doing long division correctly, the first column is always going to cancel out on every cycle. All right? That's a good sign that you've done it right. So we're left with 6x, and we carry down minus 9. So this time we're going to go a third round. Right? So you tell me, what should I consider? Not necessarily the answer, but what am I just considering? How many times will 2x go into 6x? And 6x divided by 2x is 3. So I have plus 3. Multiply that 3 through the divisor, 2x minus 1, and we get 6x minus 3, right? And then flip your signs because you're subtracting. First column there cancels out, which we now know is expected, and we're left with negative 6. I love copy paste. So if I have 4x cubed minus 4x squared plus 7x minus 9 divided by 2x minus 1, what is the answer to that division?
2x squared minus 1x plus 3.
All right, 2x squared minus x plus 3.
Minus 6 over 2x over 1.
Yep, minus 6 over 2x minus 1. That is the answer to that division. Nope. This is it. Right? In a way, we're exactly doing the opposite of what we did last time. Last time we were adding things up together and writing it over a nice common denominator. Now we've divided it back down. All right? We've divided it back down. So what if we look at 19x plus 20 plus 3x squared divided by 4 plus 3x. All right, again, it's not a monomial that we're dividing by. Anytime you got pluses and minuses in that divisor, you're going to have to do long division. So how do I set up my long division? My divisor, I will write 3x plus 4. Why is that? Descending order, right? Descending order. And what do I write?
3x squared plus 19x plus 20.
3x squared plus 19x plus 20, so that my dividend is in descending order. All right? Such a small thing, but it's important. All right? I didn't miss any terms here. An x squared, an x, a constant, so we're all good there. All right? Now I want you guys to really help me out here. What do I start with? 3x into 3x squared. How many times does 3x go into 3x squared? X. All right. Again, if I take 3x squared over 3x, I do see that the leftover there is x. It's 1x, but there's still an x. There's always an x. So where do I put it? In the x column. And then what do I write below? You tell me what to write below. 3x squared and a positive 4x. You guys agree? And then what? Flip the signs. So on this step, we were multiplying the x through the divisor, right?
Because you're doing 1 before.
Mm-hmm. And so, what's my next line? 15x, and then carry down the plus 20. Round 1, complete. You guys see what we did there? All right? Lather, rinse, repeat. Tell me what to do now. How many times does 3x go into 15x?
5
All right.
5.
Yep. 3x divided by, 3x divided into 15x leaves me with 5. So where do I write this?
Plus 5.
Yep, above the 20, I'll write a
You have
plus
to
5.
multiply the 5 times 3x plus 20.
Let's multiply the 5 through. Tell me what to write next.
15x
15x
plus 20
plus 20. Then?
plus the signs.
We flip the signs for subtraction and we get
Nothing. The remainder.
0.
So what do you get x plus 5?
Mm-hmm. So my remainder was 0. So this means 3x squared plus 19x plus 20 divided by 3x plus 4 is equal to x plus 5, and no remainders left over.
When we're writing our answer, is that how we do the tests?
Yes. Is this okay?
Yeah.
You guys see how this happened?
When we do the quiz, you want us to write like that, or you just want to answer?
Well, I need to see your whole process because you're graded on your work, but your answer would be x plus 5. Now, did this divide cleanly?
Yeah.
Yes.
So, remember how division works. If 3x squared plus 19x plus 20 divided by 3x plus 4 equals x plus 5, then x plus 5 times 3x plus 4 equals 3x squared plus 19x plus 20. You guys agree? What does that look like? Yeah. 3x squared plus 19x plus 20 happened to factor, and one of its factors was
3x plus 4.
3x plus 4. That is what happens when you have clean division. It means what you were dividing by was a factor. Shooting star moment for now. All right? But somebody did mention factoring earlier, and what did I always say about factoring?
Never, ever, ever, ever goes away.
It never does. Right here, back in your face. All right? All right. Now let's say that I wanted you to divide 2x to the fourth minus 7x plus 3x cubed minus 10 by x squared minus 2x. So far, the only operation we've been asked to do here is divide. Who knew that would be the troublesome one? Me, because I've seen it before. So let's set this one up. All right, again, it's not a monomial that we're dividing by, so we can't just do that nice trick we did at the very beginning. It's long division, and that means divisor x squared minus 2x, dividend 2x to the fourth
Plus 3x cubed
plus 3x cubed plus 0x
plus 0x squared
squared
minus 7x
minus 7x minus 10. So what did I throw out at you here? When we were putting it in descending order, right, we had to make sure we filled in any missing terms. Did I have any x squares? No. So what do I write? 0x squared. I mean, that means the same thing, right? You guys agree? All right. So descending order, and in that dividend, we filled in the missing term with a 0. Where do I start? Well, I'm going to start by giving myself a little more room, because that's going to be... Where do I start? How many times will x squared go into 2x to the fourth? Yeah, you got it. Again, if you're not comfortable yet, what do I write on the side? What should I write on the side to figure that out? 2x to the fourth over x squared. Do you guys agree? She spoke very gently. But she was correct. And what is 2x to the fourth over x squared? So 2x squared is the answer. So where does that go?
In the 2x squared column.
Yeah, over the square. So 2x squared. So see, I needed that x squared column right away because I actually had something to put in that column. That's why we need to fill that gap in. You may still work in that column even though you didn't start out with any squares. I may have even picked this example just for that reason. So there you go. It's called my job. All right, so what do we do? Yep. Take that 2x squared and multiply it through the x squared minus 2x. You do get 2x to the fourth, and then you get negative 4x cubed, and then we flip the signs. All right, we know to expect that first column to cancel, so that's a good sign, and then we get 7x cubed. Now what? Carry it all down. Plus 0x squared minus 7x minus 10. Lather, rinse, repeat. I already taught you guys to use soap. Now I'm teaching you how to use shampoo. All right. Good skills. So now I'm looking at how many times will x squared go into 7x cubed? What do you got? 7x. All right. Again, if you're not sure, how do you verify? On the side, you'd write that's 7x cubed divided by x squared, which is 7x. So that means I have plus 7x in my x column. Multiply that 7x through the x squared minus 2x, and you get 7x cubed minus 14x squared. So far, so good. Then we flip our signs, and we have 14x squared. Carry down. Minus 7x minus 10. Lather, rinse, repeat. Maybe it's the conditioner this time. You should conditioner. Another life lesson. Does x squared go into 14x squared? How many times? 14. Right? 14x squared divided by x squared is 14. So that means plus 14 in the constant column, and that means, so that's 14x squared minus 28x. Flip your signs. 21x, and then carry down the minus 10. You guys with me so far? Mm-hmm. Can I go again? The answer is no, I can't go again. How do I know?
Because that's bigger than that.
You're out of columns, that's one, and x squared does not go into 21x. That's smaller. So two big red flags flapping in the breeze that you have to brush aside to get that wrong. All right? Not that you won't try. But this is when we're done. So, 2x to the fourth plus 3x cubed minus 7x minus 10 divided by x squared minus 2x equals what? 2x squared plus 7x plus 14. That's the quotient plus
21x minus 10 over x squared minus 2x.
Yeah, your remainder is now 21x minus 10 over x squared minus 2x. Did it divide cleanly?
No.
No. There was a remainder, but we can still perform the long division. And in the back of our minds, if it didn't divide cleanly, that's not a factor. All right? All right. What if I give you f of x equals 4x to the fourth plus 6x cubed plus 3x minus 1, and g of x equals 2x squared plus 1. All right, so I've given you two functions, and I ask you to find the quotient function. That's f over g of x. All right? Ah, we did that before too, right? No escape. Okay, so how do I write the quotient function?
4x to the fourth plus 6x cubed plus 3x minus 1 over 2x plus 1.
Yeah, that was super easy. Write your f of x over your g of x, right? The thing is, now can I perform this division? Oh, yes.
Can.
Yes, we
You're
can.
missing an x squared.
Ah, so if I'm going to perform this division, what is my divisor? 2x squared plus 1. What is my dividend? 4x to the fourth.
Plus 6x squared.
Well, plus 6x cubed.
Sorry.
It's okay. You're not losing points now.
Plus 0x squared.
Plus 0x squared
Plus 3x. Minus 1.
plus 3x minus 1. You guys agree? Descending order for everything, and then for our work area, we fill in missing terms.
That means in terms always positive.
I mean, you could write minus 0 and it's the same thing. If you just happen to be a negative person. That's a good question. 0 is the same plus or minus. It's the only number that's like that. So you guys okay with the setup? You guys with me on the setup? So let's see how this works. Where do I start? You're just going to wait for me to draw it.
4x to the fourth. How many times can 2x squared go into?
How many times can 2x squared go into 4x to the fourth? 2x squared. Again, on the side, you could write 4x to the fourth divided by 2x squared to get the answer of 2x squared. Right? No shame. That's perfectly fine. So I put this over my square column. And then what do? Multiply that 2x squared through the divisor of 2x squared plus 1. So that's going to give me, we get 4x to the fourth, and then we get 2x squared. Right? 2x squared times 1 is times 1, folks. 2x squared. So what happened here? Yeah, line it up with the square term. Right? Do you see why we might have a gap? There's a gap in our divisor. Right? If you want to write it as plus 0x, you could have. Right? Not that we have any work columns over here, but it might give you that heads up. Flip your signs to subtract, and what do we get? 6x cubed minus 2x squared. Carry down, plus 3x minus 1. Let me see some neck action. Do you see how round 1 went? You guys in the back okay? Right, do you see what happened? All right. This is why neatness matters. You start slapping crap everywhere on the page. First of all, I have to grade that, and that's going to make me unhappy. Right? So partial credit's going to be stingier. But maybe if you do it like in a sparkly purple, then I'm happy and partial credit goes back up. I don't know. It pays to be nice to the instructor. All right. Lather, rinse, repeat. 2x squared goes into 6x cubed 3x times. Are you guys all okay with that? Again, if you want to show it on the side, 6x cubed divided by 2x squared gives me that 3x answer. Then that 3x gets multiplied through the divisor, 2x squared plus 1, and we get 6x cubed, and then we get 3x. And then flip the signs for subtraction. Indeed, we get negative 2x squared. I'll go ahead and write plus 0x minus 1. Can I go again? 50-50 you guess right, even if you don't know anything. And I'm hoping at this point you at least know a little something.
Negative 1?
Yeah, we do go again. 2x squared goes into negative 2x squared, negative once. On the side, if I take negative 2x squared divided by 2x squared, I get negative 1. And so we write minus 1, and then that minus 1 gets multiplied through negative 2x squared minus 1, and then flip your signs because we're subtracting, and then
0x.
0 everything.
Can you just skip that and just bring the 1 up? To the top?
No, you're not always going to wind up with 0. Okay. And so, I can simplify this function. Right? What's it going to be? Mumble, mumble. 2x squared plus 3x minus 1. Did it divide cleanly?
Yeah.
So what do you think that means?
There's a factor.
Yeah. 4x to the fourth plus 6x cubed plus 3x minus 1 factors. One of its factors is 2x squared plus 1, and the remaining factor is 2x squared plus 3x minus 1. If it divides cleanly, then that is a factor. You could remultiply this out to verify, and you'll get that answer back. Because we don't know ahead of time that it's going to factor. For example, did this divide cleanly in this example? No, we didn't have 0 as a remainder. Since it didn't divide cleanly, it wouldn't have factored. Right, it's a very good question, and one that we will answer in pre-calc algebra. Right. All right, so how do you guys feel about that long division? How many of you guys have done this long division of polynomials before? Any of you done long division of polynomials before? All right.
What about
Synthetic division?
Yeah, what is that?
We're not going to do synthetic division. It works in a very specific case, and you'll do it in college algebra.
Oh, okay. Because as soon as this happened, that's what I thought of.
It wouldn't work for this one, for example. Synthetic division wouldn't work on this one.
So everything that factors at some point you can make long division of?
Mm-hmm. Yep, there's one of the tie-ins. All right, so long division is going to be one topic that you should spend some time on. All right. So let's move to our next section. 15.5. Right? complex fractions. You just know from the name you're going to love this one. So in 15.5, we're going to talk about complex fractions. So first off, what do we mean by a complex fraction? Yeah, a complex fraction means you have fractions within a fraction. All right? This is like inception level math nightmare for you guys. All right? Some examples being -1 over AB divided by 2 over B, and 1 plus 3/4 minus 1/6 divided by 1/2 plus 1/3. So what's really important for you guys to keep in mind is the main fraction bar in a complex fraction. So the main fraction bar divides your complex numerator and denominator. All right? So in the first case, what is your numerator? -1 over AB is your whole numerator. And what is your denominator? Yeah, I mean, I circled it, so I'm really hoping you guys can just read. 2 over B. Is that okay? Now, am I dividing a single fraction by a single fraction? We've seen that before, right? Wink, wink, nudge, nudge. However, in the case next door, what's my numerator? 1 plus 3/4 minus 1/6 is the whole numerator, and the denominator is 1/2 plus 1/3, right? Am I dividing a single fraction by a single fraction? No, not in that case. That's more complicated, right? But both of these are complex fractions. We have fractions within our fraction. Now, method 1 only works when you have a single fraction divided by a single fraction. So it's very limited, right? But this we already know how to do. If I have a single fraction divided by a single fraction, what do? Yeah, multiply by the reciprocal. We saw that before, right? But now we have to keep in mind that's very limited. It only works when single fraction divided by single fraction, right? So this method's nothing new. But in the case of 1 over AB over 2 over B, it'd be 1 over AB times B over 2. You guys agree? Which is? Yep, it reduces. I'm going to go ahead and reduce the B's.
1/2.
1 over 2A.
Over 2A. I don't want to say it for some reason.
It's all right. Right? But that's what we've seen before. That part's not new. All right, but we're more interested in a method that works all of the time. One-stop shopping is what we do, right? So, since they called one method method 1, guess what?
Method 2.
There's a method 2. Right? Now, this method will work all of the time for a complex fraction, where method 1 works and where method 1 wouldn't work. The key to simplifying a complex fraction, then, is the LCD. All right? Finding the LCD from all the individual fractions within your complex fraction. Then you're simply going to multiply the numerator and the denominator by that LCD. All right? So in one fell swoop, we kill off the complex fraction. Now, it'll still be a fraction, but it won't be a complex fraction. It won't have fractions within the fraction anymore. Of course, the last step is to check to see if it simplifies, but what's the key thing for simplifying? It's that F word, factoring. All right. Not the other one. That's how you're going to feel on the homework. So if we looked at their example, 1 over AB over 2 over B, we get the LCD from all of the denominators within the complex fraction. So what is your LCD for AB and B? AB, not the GCF, the LCD. Right? For AB and B, the LCD is AB. You guys on board? So I'll multiply the top and bottom of the main fraction bar. Right? As long as I multiply the top and the bottom of a fraction by the same thing, it's okay, right? What happens when I multiply AB into the top? Yeah, it cancels out to just 1. What happens when I multiply AB into the bottom? You get 2A and the B's cancel, right? That's B divided by B. And what did I get? Same answer, right? We should. It was the same question, so it should have the same answer. It did. All right. But now I can use this on the second example. 1 plus 3/4 minus 1/6 over 1/2 plus 1/3. I'm going to simplify this complex fraction. What is my LCD? Well, 4 won't go into 6. So that's a nice try, but it wasn't quite there.
2.
Not GCF, LCD. 12. 24 is a common denominator, but it's not the least common denominator. All right? All right? We needed something that 1, 4, 6, 2, and 3 will all go into. All right? And we practice finding LCDs. You could break it down piece by piece. Right? And then what do I do with that LCD? Multiply it through the top of the main fraction bar and multiply it through the bottom of the main fraction bar. So if I multiply 12 in through the top, what do I get? 12 times 1, 12. Plus, that's going to be, wouldn't the 4 reduce 12 to 3? And 3 times 3 is 9. Minus, the 6 would reduce the 12 to 2, and 2 times 1 is 2. So my whole numerator is just 12 plus 9 minus 2, fraction free. In the bottom, multiply by 12. Six plus 4. You guys all on board? Do you see how that happened? All right? No longer do we have a complex fraction. It's just a regular fraction. You didn't know you'd live to see the day that the regular fraction was the prize. Well, hopefully at this point it's easy. What do you get? 19 over 10 is the answer. Does it reduce? No. That's it. All right. So we level up. Let's say that we have 6x over x minus 5 divided by 12 over x squared minus 25. Complex fraction? Yep. You've got fractions within a fraction. Is it a single fraction divided by a single fraction? Yes, which means we could use method 1. Method 1 says this is 6x over x minus 5 times x squared minus 25 over 12. Do you guys see how I worked that? This is the last time we're going to use method 1 in this section. It's all going to be method 2. But just so you guys see that it is there. That's like what we were dealing with before. It does reinforce what we were doing. How does this one work? Factor everything completely. All right? So we got 6x, we got x minus 5, and then we got, yeah, it's the difference of squares. X plus 5, x minus 5 over 12. Yeah, now you can just connect the fraction bars because that's how multiplying fractions works. And we do have some simplification. What can we reduce? 6 will reduce the 12 to a 2. X minus 5 divided by x minus 5. We're left with? X times x plus 5 over 2. You guys agree? I would leave it factored. Factored is nicer here. You worked so hard on factoring. Enjoy the fruits of your labor. All right, but I said method 2 always works. That means if I do this one again, I can do it with method 2 as well, right? So method 2 means find the LCD. That's the key. And really, when you see a complex fraction, that is the tool in your algebra tool belt that you should reach for, is the LCD. Now, in order to get an LCD, you have to factor all the denominators, right? That means x squared minus 25 factors into x plus 5, x minus 5. Meanwhile, x minus 5, that's already factored. It is what it is, right? So, looking through the denominators within your complex fraction, what is your LCD? X plus 5, x minus 5. Or if you put it in the other order, x minus 5, x plus 5, that's totally fine too. Right? And then what do we do with the LCD? Multiply to the top of the main fraction bar and multiply to the bottom of the main fraction bar. If I hit the numerator, 6x over x minus 5, with that LCD, what happens? You get 6x times x plus 5. What happened to the x minus 5? It canceled out. If I hit the denominator with the LCD, what happens? I get 12. What happened to the x plus 5? It canceled. What happened to the x minus 5? I heard it whispered on the winds. It canceled. Do you guys see that? Do you guys see that it canceled out? Right? And we no longer have a complex fraction. In one fell swoop, the LCD kills the complex fraction. Now, does this simplify? Now, here's the good news. In order to simplify, you must be factored, and we already are. So we can reduce by 6, and my final answer is x plus 5 over 2. Right? Do you see why I might favor that second method? Even in the case where method 1 works, really method 2 is nice. So let's say x over y squared minus 1 over y, all divided by y over x squared minus 1 over x. Complex fraction, right? Is it a single fraction divided by a single fraction? No. So the only thing on our agenda, method 2, which asks us to use the LCD. Right. Now, I'm never going to have a test question where I say use method 1 or use method 2. So if you learn method 2, just use method 2, right? That would be, you know, wink, wink, nudge, nudge, my hint to you guys. All right, nothing needs to be factored in this case. We can go ahead and get the LCD, and the LCD is, he suggests x squared y squared, and I wrote it down, so that's a nice vindication. Do you guys agree? Is that okay? Looking at y squared, y, x squared, and x, the LCD that they could all go into is x squared, y squared. Do not get greedy with your LCDs. All right? Don't take too much. You can actually wind up in a situation you're not prepared yet to reduce. All right? So only take the LCD. And then what do we do with it? Multiply the top of the main fraction bar and the bottom of the main fraction bar. So what survives the slash and burn? We start off with x cubed. How'd I get it? The y squared will cancel, so you're just left with x squared times x, which is x cubed. Minus, what's going to happen with the second one? X squared y. One of the y's canceled, so we're left with x squared y times 1, which is x squared y. And that's my numerator. All right, what's going to happen in the denominator? So we're going to wind up with x squared canceling, and y squared times y is y cubed. Minus, and what happens with the final term? What cancels?
X.
Just an x, right?
Yes.
So xy squared times 1 is xy squared. Neck action. You guys on board? Is this okay? Right, do you see what happened? Christy.
I need a step by step.
This is it. All right. You guys okay? So, our goal here was to kill off the y squared, the y, the x squared, and the x. That's what's making it a complex fraction, right? So the LCD is what does it. It's going to cancel all of those out. Now there's going to be stuff left over, right? If I cancel out a y squared, what's left over? An x squared times the x that's already there. If I cancel out a y, what's left over? X squared y times the 1. If I cancel out an x squared, what's left?
Y squared.
Y squared times the y that's already there. So y cubed. And if I cancel out an x, what's left over? Xy squared times the 1 that's there. So that's what we're doing, right? Should feel good. You're killing fractions left and right. You've been wanting to do it for a long time. But you have to do it legally, which I guess takes the fun out of it for you. All right, so we're done with the complex fraction, but the last step was to check to see if it simplified, which means we have to factor it. Can I factor anything out? I can factor an x squared out of the top, leaving me with x minus y. You guys agree? Now, the numerator was written in descending order for x, right? Is the denominator written in descending order for x? No, that would be negative x y squared plus y cubed if I wrote it in descending order for x. You guys agree?
Yep.
So what should I factor out there? Factor out a y squared as the GCF, but should I exercise my option to factor out the negative? Because my leading term is negative, I would say yes, leaving behind x minus y. Yep.
Why do we put it with the leading x instead of the term of the highest degree?
We are looking at it, but only in terms of one of the variables. So if I choose x, I want to put the highest degree of x first. And if you could have also chosen y, but you know, we always go back to x, don't we? It's bad in life. In this case, we do have x minus y divided by x minus y, and that leaves me with negative x squared over y squared. Now remember, when you have a fraction, you can write the negative on the denominator, you can write the negative on the numerator, or you can write it in front of the fraction bar, right? So usually we choose to write it in front of the fraction bar, but it's fine either way. This is my answer. Who saw it turning out that nicely? Let's try another one. One is never enough. What if we had 1 over x plus 6 minus 1 over x all over 6? Complex fraction, right? Is it a single fraction divided by a single fraction? Nope, that means, yep, method 2, which tells us to use LCD. What is the LCD here?
X plus 6.
All right, we do need an x plus 6.
You need an X.
We also need an x. And that's it. So I could think of 6 as 6 over 1, right? You guys agree? So we get our LCD by looking at all the denominators. I have an x plus 6, an x, and a 1. So what is my LCD? X plus 6. Or if you really want, x plus 6 times x is fine too.
That's what I did.
What matters is what we do with it. And what do we do with the LCD? Multiply the top of the main fraction bar and the bottom of the main fraction bar. Now this is good news. We should be able to kill stuff off. That's the objective, right? So what happens with that first term? What's going to cancel? If I cancel x plus 6, what's left? X times 1, which is x minus. What happens with the second term? Who cancels? The x cancels. So what are you left with? X plus 6 times 1, which is x plus 6. Now that negative applied to the whole second fraction, right? So it should still apply to the whole second term. All right? In parentheses, x plus 6. Is everybody okay with that? Now this one's so easy it's hard. What happens in the denominator? What cancels in the denominator? Nothing cancels. So what do we get? 6x, x plus 6. So this is what we're left with. X minus x plus 6 in parentheses over 6x, x plus 6. And that denominator is nicely factored for us. So don't reinvent the wheel. All we have to do is clean up the numerator. So what should I do in the numerator? Distribute the negative. X minus 6. And then x minus x cancels to 0. So you just get negative 6 over 6x, x plus 6. You guys agree? Is this fully factored? Yes. Does it simplify? Yep. Once it's fully factored, what can I cancel? 6 will reduce 6 in both cases to 1. So we're left with negative 1 over x times x plus 6. And that is our simplified answer. Right? So in one swoop, you identify the LCD, you kill off the complex fraction. Then really, most of the work is spent doing the simplifying process, which is the first thing we did in chapter 15. All right, let's level up. All right. What if I give you 5 minus 3x to the negative 1 over 2 plus 3x in parentheses to the minus 1? Is this a complex fraction?
No.
What was the name of the section?
Complex fraction.
Complex fractions. So guess what?
Yeah.
It's a complex fraction.
Never would thunk it.
But it's hidden, and it's understood that you guys might not recognize it. What do the negative exponents mean? You flip it into its own denominator, right? But the key thing here is that plus and minus messes that up. So in the numerator, I'd have 5 and I'd have minus. I mean, hopefully nobody's shocked at that part. And then I would have 3 over x. Who was raised to the negative exponent there? X. So what did I do with it? Flipped it into the denominator with that 3 being the numerator. Main fraction bar. Now you guys help me with the denominator. Yep, so we got 2 plus 1 over 3x. Who is raised to the negative exponent there? The whole 3x. So guess what? It flips into its own denominator. All right? Boy, did you miss a doozy of a step. All right? Don't trip and break your neck on the way over. Or if you do, make it entertaining. But we've exposed this complex fraction. Now it's laid bare for all to see. And it's not a single fraction divided by a single fraction, so it is method 2. Use LCD. What is my LCD? You guys seem to really struggle with LCD, more than I've had a 1033 struggle before. So let's see. Can you guys come up with the LCD? Mumble, mumble.
3x.
Your LCD is 3x. So what do we look at? The denominator of 5 is 1. The denominator here is x. The denominator is 1. The denominator is 3x. So the LCD, 3x. Now what do we do with the LCD? Multiply the top and bottom of that main fraction bar by that LCD. So with the 5, does anything cancel? No, so we get 15x. With 3 over x, what cancels? The x, so we get 3 times 3, so minus 9. That's the numerator. Everybody on board? So what do I write in the denominator? 6x plus 1. 6x plus 1. 3x divided by 3x is still 1. You guys see how we use the LCD? Can I factor? What do I have? I do have a GCF in the numerator of 3. If I factor out a GCF of 3, that leaves 5x minus 3. But the denominator is 6x plus 1. And there's nothing to be done with that. For binomials, if there's no GCF other than 1, the only things we have are difference of squares. Nope. Difference of cubes. Nope. Sum of cubes. Nope. This is it. It is what it is. So either one of these is perfectly fine as a final answer. It's just you're going to have to factor to check if it simplifies anyway, so might as well just use the factored form. Is that all right? Let's try another one of those sneaky hidden ones. what if I give you a to the negative 1 plus 2a to the negative 2 over 2a to the negative 1 plus parentheses 2a to the negative 1. Spoiler alert, this is a complex fraction. So my first step is to expose it. How shall I write the numerator? 1 over a She got it. 2 over a squared. Do you guys see? There's your numerator. Big fraction bar. What do I do with the denominator? Very good. 2 over a plus 1 over 2a. Now, she was very good. You guys all just like let her do the work for you. So now your neck has to make up for it. Yes, no? Did you see what happened? Right, did you see what happened there? Right, do you see the difference in why some of the 2's came down and some didn't? Right, what was the difference? Yeah, those parentheses included it in the base or didn't. And that made the difference. So we've exposed the complex fraction. Now that we've exposed it, kill it. Kill it with fire. And by fire, I mean the LCD. Two a squared is right. Now you guys got confident. All right. Yeah, between a squared, a, and 2a, I need a 2a squared. That is my LCD. That takes care of everything. Is that okay? But don't get greedy. If you go too high, if you don't take the least common denominator and you take a higher common denominator, you can sometimes wind up with things you're not equipped yet to factor. So what do? Take that LCD and multiply it times the top and bottom of the main fraction bar. So let's have a go. With 1 over a, what would cancel? An a, leaving behind 2a times 1, which is 2a. Plus, with the 2 over a squared, what's going to cancel out? A squared, leaving 2 times 2, which is 4. There's my numerator. What about my denominator? An a cancels, so you have 2a times 2, which is 4a, as some of you guys were saying. And finally, 1 over 2a, what happens? The 2 cancels and an a cancels, leaving behind just an a times 1, which is a. So 2a plus 4 over 4a plus a. Do you guys see how that worked? Right? We start to feel comfortable, right? Maybe a little more. Right? Not so much that if I give you the test right now, you'd ace it, but you'll go do the homework, and then you'll ace the test. Right? Now what happens? In order to reduce, which is what we need to be looking at, we need to factor. So look at the top. I have a GCF of 2. If I pull out a 2, I'm left with a plus 2. Now the bottom is so easy it's hard. 5a. Aren't they like terms? 4a plus a is 5a. Now let's say you missed it. You'd say, oh, a GCF of a, right? But if you factored out the a, what would be left? 4 plus 1?
Oh.
There you go. Right. All roads lead to the right answer unless you crash and go off-road. Not my recommendation. Does anything reduce? Nope. This is our answer. This is my answer. All right. What if we attempted 7x over 2x minus 2 plus x over x squared minus 1 all over 4 over x plus 1 minus 1 over 3x plus 3. On the one hand, I didn't give you a hidden complex fraction. It's staring you in the face. But on the other hand, it's got a pretty mean stare. You're whimpering like little chihuahuas. Actually, chihuahuas are always mean. They just think they're big old German shepherds. It's a lie. So what am I going to need to do here?
Well, method 2.
Yeah, it's definitely method 2, and that means I need an LCD. So in order to get an LCD, I need to know what denominators I'm working with, right? Yeah, we got some factoring to do. So what can I do with those denominators? Let's start with the start. It's a good place to start. There's a GCF of 2 that I can pull out of the first one, leaving behind x minus 1. All right, next up, that's a difference of squares, so x plus 1, x minus 1. Remember when you guys thought that was hard? Not that long ago. What about x plus 1? It is what it is, right? What about 3x plus 3? 3 times x plus 1. Is everybody okay factoring out these denominators? All right. Somebody called an ambulance.
Why is there like 100? Because we're killing fractions.
Yeah, I like it.
100 of them. It's distracting. Who's dying, man?
X plus 1, x minus 1.
Yeah, let's identify our LCD. And we got a couple of things we need here. You have an x plus 1 and an x minus 1, that's for sure, right? And then I heard 6. Right? Suddenly you guys are LCDing like champions. Right?
Oh my gosh.
You got to consider all of your denominators. I have to take care of a 2 and an x minus 1. I have to take care of an x plus 1 and an x minus 1. I have to take care of an x plus 1, and I have to take care of a 3 and an x plus 1. So what all do I need? Just take it a little piece at a time. I need an x plus 1. I need an x minus 1, right? How do I know that I don't need squares? I don't have any, right? It really is that easy, right? So what about the 2 and the 3? What's going to take care of a 2 and a 3? 6. Yeah. Multiplying is a sketchy trick that'll get you an LCD, but it's not always the, it'll get you a CD, but not always the LCD. Right? For example, what's the LCD of 6 and 12? LCD, not GCF. 12, right? You could multiply them, but that's overkill. 72 is way more than you needed. Right? And like I said, if you get greedy with your x's, that's going to blow up in your face. Another life lesson on top of a math lesson. So what do I do with the LCD? Main fraction bar top, main fraction bar bottom. All right, so we got a little bit more going on here. Mathematically, it's the same as what we've been doing, but there's a little bit more to consider. With my first term, what is canceling out? An x minus 1, and the 6 is reducing to 3. So I've got a 3 and an x plus 1 times a 7x. So I have 21x, x plus 1. Do you guys see that? All right. The x minus 1 will cancel. The 6 is reduced by 2 to a 3. So 3x plus 1 times 7x is 21x, x plus 1. Next up, my second fraction. What happens here? The x plus 1 and the x minus 1 cancels, and we get 6 times x, which is 6x. And that's my numerator done. At least as far as the complex fraction is concerned. You guys with me on that? All right, denominator. 4 over x plus 1. What's going to happen here? What cancels? Just the x plus 1. So I have 6x minus 1 times 4. What's that going to be? 24x minus 1. And last but not least, the 1 over 3x plus 3. What's going to happen here? What cancels? X plus 1 cancels, and 6 is reduced to 2. So I have a 2 and an x minus 1 times 1, which is 2 x minus 1. All right? Vigorous neck action.
How did it become positive? 2. Oh wait, never mind.
That was an
You said
easy
2.
question.
Yeah, I know.
You guys in the back? You guys doing okay?
Because I just heard you say 2, not -2. I was listening. Not
Yeah, I'm sorry. I carried down the minus. I didn't say it. So
Okay,
for
it's okay.
posterity's sake,
I wasn't looking up.
it's good. All right. So in the numerator, I should multiply that all out. So this means I wind up with 21x squared plus 21x plus 6x. You guys agree? Now, what do you see in the denominator?
Oh, no, I don't.
They combine. Aren't those like terms?
Yes.
24x minus 1 minus 2x minus 1 is 22x minus 1. Okay. They're like terms. Right? 24 bananas minus 2 bananas is 22 bananas. Okay. Now, if you distributed and then combined like terms and then factored it back out, you'd get to the same place. It just took you a couple more steps to get there. Okay. But I like this because now the denominator is factored. The numerator, on the other hand, still got some work to do there. So it's going to be 21x squared plus 27x.
Oh, because you just combined them.
Yep, we have 21x and 6x, which are like terms. And now that I've combined like terms, can I factor anything out of the numerator? We can factor out 3x, which would leave behind you started strong and then just died on me. 7x plus 9? So 3x, 7x plus 9 over 22x minus 1. Does anything cancel? Nope. This is the answer. This is our answer.